Honors Algebra 2 Pre-Calculus. We're doing 10.4 in Pre-Calc, which is hyperbolae, but now we're actually doing something that talks about all sorts of conics. So there is a general form of a conics equation that can be written sort of like the boring general form that you used to have for linear equations, like ax plus by plus c equals 0. Well, there's a generic version of the conic equation. Sort of this general version is ax squared plus cy squared plus dx plus ey plus f equals 0. The cool thing if something's written like this is while it would take a lot of work to simplify the equation into standard form, whether it's an ellipse or a hyperbola or a circle or a parabola, you can identify very quickly, looking only at a and c, the coefficients of x squared and y squared, you can identify which of the 4 parabolae you are looking at. If a and c are the same number, it's a circle. Might take a lot of work to simplify it, to complete the square and make it look like a circle, but if a and c are the same number, it's a circle. Not the same number, opposite sign, the same number, exactly the same. If a is 5, c is 5. If a is negative 10, c is negative 10. If a times c is a 0, but a and c are not both 0, then it's a parabola. Now let's think about that logically for a sec. If one of these coefficients were to be 0, only one of them, let's say a is 0, well now you have something with a y squared but a linear x. Well, that's definitely a parabola that opens left or right. If c were 0, then ac would be 0, and you'd have something with an x squared term but only a linear y. Well, that's definitely a parabola that opens up or down. The reason there's the caveat that they both can't be 0 is if both of them were 0, you'd have a linear equation, which is still a conic, but it's a degenerate conic, so we don't list that here. And that's what that note says at the bottom right here. It says if both a is 0 and c is 0, then it's a line, which is a degenerate conic. So again, if a times c is 0, it's a parabola. The other easy way to spot that is if you notice that only one of the two variables has a squared term, you're looking at a parabola. If a times c is positive, so ac is greater than 0, then you're looking at an ellipse. And that makes sense because in an ellipse equation, both the x squared and the y squared end up being positive. So they have to have the same sign when you clean the whole thing up. So if a and c have the same sign, you're looking at an ellipse. And if a and c have opposite signs, totally different numbers, doesn't matter what the numbers are, but if the signs are opposite, if a times c comes out negative, then you have a hyperbola. So if you're anything like me, and maybe you're not, and that's probably good for you as a human, but if you are, when you looked at this, one of your first thoughts was, why isn't there a B? That's really annoying, right? Like, I mean, A, C, D, E, F. My son's only 2, and he knows that after A comes B, or I think he does. Anyway, it's unclear. Point being, that's probably a thing that bothered some of you. So why no B? Well, there is a more difficult version of this equation, and I'm not sure how well you can see what I put at the bottom, but I'll walk you through it. There's a more difficult version of this equation that you need a little bit more knowledge to deal with, so we're not dealing with here. And in that more difficult version, there is a term that is x times y, right? Here you don't have any x and y terms. You have x terms, you have y terms, but you don't have any mixed terms that are x and y. The coefficient of that term is b. So in this more complicated equation, it's ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. And that's why there's no b. It really bothered me the first time I saw it. I couldn't, I don't know. It was really frustrating. So all of this information is on page 731 in your book. I don't think they address the lack of a b. Maybe they do somewhere. But anyway, so that's the gist.